to a new paging group, the mobile station performs an paging group update to the base station. So the key difference between sleep mode and an ideal mode would be presented later. So, but essentially, in ideal mode, the device listens through a paging interval, and in an ideal mode, device deregisters from the base station and goes into idle connection and actually saves a tremendous amount of resources from the base station. In sleep mode uh, operation, mobile station conducts pre-negotiated periods of absence from the serving base station air interface. The sleep mode is triggered by unavailability of downlink or uplink traffic for a particular amount of time, and if there is no traffic during those period, the base station can ask mobile station to go in sleep mode, and mobile station remains in sleep mode during interburst intervals. To facilitate handoffs while in a sleep mode, the mobile station is allowed to scan other base stations to collect handoff related information. Sleep mode benefits the base station by by relieving resources from the base stations. Has also advantage to mobile station by saving power, and also mobile station scan other base station to collect information to assist handover during the sleep mode. So, in nutshell, when a mobile station goes to sleep mode, it actually is registered in the base station, but is actually not doing a data transmission and goes to an absence period. In an ideal mode, the mobile station actually gets deregisters from the base station and frees that particular service flow for new user to take place. This is the last section of the presentation, and essentially in this section, WiMAX security aspects are presented. So 802.16e standard specifies a number of advanced security protection mechanism, which includes mutual device and user authentication. It has a flexible key management protocol structure, strong traffic encryption and control mechanisms, and also has protection for management messages. The IEEE approach to standard-based security relies on privacy and key management protocol version, which is called PKMV2, as a key management protocol that enables crypto key exchange for authentication, encryption, and protection for multicast and broadcast traffic and normal data traffic. The PKM version 2 based WiMAX standards addresses both device and user authentication, and by using IETF's EAP protocol method. So WiMAX supports all the EAP methods that we are described in IETF. For example, EAP TLS, EAP TTLS, EAP AKA, EAP SIM, etc. And it uses an advanced encryption standard, which is AES CCM, as the cipher to encrypt subscriber traffic over the air, and as a further protection, a traffic encryption state machine uses a periodic key refresh mechanism to enable sustained transition of keys. So in nutshell, WiMAX 16e has an set of security protocols and features which are very robust and allows very secure transmission of data over the air network. So in this security framework, the mobile station and base station is encrypted through an AES CCM ciphers over the air, and then once the mobile station initiates an PKM version 2 over EAP base station forwards the relay protocol to an EAP authenticator, and the EAP authenticator forwards the EAP over radius to an AAA server, which has which can be used as an method to do an EAP certificate based authentication or an username and password based authentication. So an end-to-end authentication and exchange framework is supported in WiMAX, which is based on PKM and IETF EAP. In slide 28, the key exchange framework of PKM version 2 over EAP is explained. So in the first step, the mobile station completes its capability negotiation with base station in SBC request message, and then initiates the PKM version 2 protocol, which from base station to ASN gateway triggers through an EAP start message, and then ASN gateway and the mobile station does an EAP identity request, and then this EAP identity request is forwarded to a AAA server, and after that AAA throws an MD5 challenge, and once MD5 challenge is completed, then both mobile station and the AAA would establish and master key session generation. So master session keys would be generated in mobile station and AAA, and then MSK would be transferred to ASN gateway, and ASN gateway then generate and with mobile station generate a pairwise master key which is called PMK, which will derive an authorization keys, and then this authorization keys is transferred to an base station. Base station will do an three-way handshake with mobile stations, and in turn will generate an traffic encryption keys, and these traffic encryption keys would be used to encrypt data traffic from here. So this is the whole key exchange framework which is supported in WiMAX to establish a secure data connection, and this exchange framework is also used to periodically refresh new data, new TE keys for periodically to have much secure transmission. So that's all pretty much from this section, and in my next presentation we will cover WiMAX network architecture. Thanks for listening. Bye.